So the test for bonding is going to be multiple choice and a couple of short answers. You should study your notes, your review, and your worksheets. This is part 2 of the chapter that we did, so it's going to focus more on the covalent compounds like the molecular geometry and nonpolar polar, but you still do need to know some of the ionic, especially the differences between the covalent and the ionic. As far as the definitions, the best place to look for those, or actually the quickest place, is in your textbook under Chapter 6. Go to the chapter summary, and remember all of those definitions are listed there. You can also find them in your notes, but you'll have to search through your notes because they're going to be scattered throughout the notes, whereas at the chapter summary they're all right there together. But I'm not going to spend time in the review going over definitions when you can easily look those up. Question 2 says blank electrons are involved in the formation of chemical bonds, and that is the valence electrons. And remember, the valence electrons are found in the outermost s and p orbital. Number 3, how does combining atoms in a chemical bond affect their stability? And remember, we said this, that it increases their stability, and it does this by the fact that it's lowering the potential energy of the two separate atoms. And then question 4, what kind of bond is formed when two atoms share? And remember, sharing is carrying. Don't be ionic, be covalent. So sharing is a covalent bond. And then, of course, the transfer of electrons is an ionic bond. Question 5 wants to know what kind of atoms will form a non-polar bond, non-polar covalent bond, and that is usually two of the same nonmetals. For instance, if we have a chlorine and a chlorine bonding, that would definitely be non-polar covalent. Remember, it is supposed to be less than a 0.3 electronegativity difference. So there are a few things that can still be nonpolar that are not the same, but they have a very, very small electronegativity difference. 6, it says when atoms share unequally, what kind of bond do we have? And that is where we have the polar covalent. Remember, that is whenever we have a bond and this side would be slightly positive, this side would be slightly negative, because chlorine actually gets the electron more, and so it's slightly negative on that charge. We call those dipoles. They created dipoles. Number 7, why are nonpolar covalent bonds uncommon? And they're uncommon because there's usually one atom that has a stronger attraction for the electron. Remember, the higher the electronegative an atom is, the more it gets the electron. Of course, fluorine is the highest, but there's very few things that have that less than 0.3 electronegativity difference, and so that's why it's uncommon. All right, question 8, what is a neutral group of atoms held together by covalent bonds? And remember, a covalent bond, we call it a molecule because it's literally stuck together because the orbitals are overlapping in order to share their electrons. Remember, an ionic bond is called a formula unit. The octet rule, number 9, is that atoms will either gain, lose, or share electrons in order to achieve 8 electrons in their outer shell. Group 18, the noble gases, already have their 8. That's why they are not reactive, because they have their full outer shell. Number 10 wants to know how many electrons does phosphorus need to satisfy the octet rule. Phosphorus has 5. It's in group 15, so it has 5 valence electrons, so it needs 3 more to be able to get its octet. So it will either gain 3 or it will share 3. Number 11, how many electrons does sulfur need to satisfy the octet rule? Sulfur is in group 16. That means it has 6 valence electrons. And so it needs 2 more to get to its magic 8. Number 12, which group satisfies the octet rule? We kind of just answered that in number 9, but it's group 18, the noble gases. 13, when you finish drawing a Lewis structure, how can you tell to see if it's right? Remember how you need to add up all the valence electrons for all the atoms involved, and then you will count the total number of valence electrons in your Lewis structure, and they should match. All right, so here's the structure for HBr. We would expect there to be 8 valence electrons, And so when we draw it, we see that there are 2, 4, 6, 8 all the way around. Because there's only two things, it would be a linear molecule. Anytime there's only two atoms bonded to each other, there's not going to be a central atom, and so it's going to be linear. There is no bond angle since it is only two. And then even though this doesn't ask about it, we're going to stay in the habit. And because this is not symmetrical, this would be a polar molecule. All right, so this is what the structure for CF4 should look like. You should have 4 bonds on carbon. Remember, carbon always gets 4 bonds and it never has lone pairs. So we attach our 4 fluorines to our carbon. We give fluorine, it's 8 because it's going to have an octet. And when we do that, we see that we do match up the 32 total electrons that we said it needed to have. Anytime it has some 4 things bonded to the central atom and 0 lone pairs, that's going to make it tetrahedral, which would give it a bond angle of 109.5. And then, of course, if we look at the molecule itself, we see that it is symmetrical all the way around, so it would be a nonpolar molecule. So this is what NH3 would look like. It would have a pair of lone pairs at the top with 3 hydrogens coming down from the bottom portion. The structure, because it's 3 atoms bonded to the central atom and 1 lone pair on the central atom, would be trigonal pyramidal. That gives it a bond angle of 107 degrees, and it is not symmetrical all the way around when we look at it. Remember, we're thinking of these as a round molecule, and of course this area at the top would have a slightly negative charge because of those lone pairs of electrons, so it would be a polar molecule. Number 17, what is a molecular formula? And a molecular formula is one that has covalent bonds. Remember, we call covalent bonds molecules. The chemical formula is the formula that shows the number of atoms and how many of each kind. And that can either be an ionic, covalent compound, either one. It is a chemical formula, and I've given you some examples there. Number 19 says what 3 elements are often found to form multiple bonds. That means double or triple. And carbon and nitrogen and oxygen are the big 3, but also sometimes we tend to forget that sulfur can also form a double bond. All right, 20, which has a higher boiling point, a molecular compound or a compound that's bonded ionically, and the ionic compound will definitely have a higher boiling point. What we use to show resonance is a double-headed arrow. And remember, resonance is when we draw a Lewis structure, and usually if it has a double or a triple bond, sometimes we don't always know exactly where that bond is. Is it between the first and second carbon, or the second and the third, or the third and the fourth? And so when that happens, we show all the possibilities of where that bond could end up, and we draw that double-headed arrow, and we consider that to be a resonance structure. So I tried to copy this chart out of our notes, but it didn't work out so well. So I think you can read it. If not, please refer back to your chart in your notes. But this was a good table to compare and contrast the differences between ionic and covalent bonding. So make sure you look over that. Sorry for the quality of the graphic when I did the snipping tool. I guess it didn't convert very well into this program. So the last thing is be able to predict shapes and bond angles. I put this one in there from the notes because I didn't have the other chart with me at home. But the chart that we filled out in class together, that would be the better chart to study because it actually gives the bond angles, whereas this one doesn't. But let me go ahead and jot down these. For trigonal planar, the bond angle is 120 degrees. For bent or angular, it's going to be 104.5. For tetrahedral, it's going to be 109.5. For trigonal pyramidal, it's 107. Bent or angular, again, is 104.5. And then down here with octahedral and trigonal pyramidal, they give you those right there and there. So make sure you understand how to read this. If something, for instance, if something had 3 things bonded to it and 0 lone pairs, that would make that a trigonal planar structure. Whereas if something has 3 things bonded to it and 1 lone pairs, that makes it the trigonal pyramidal structure. Okay, as suggested today in fifth period, we're going to do some Christmas jokes. So I thought I would do some snowman jokes. So here we go with the first one. What do snowmen wear on their heads? They wear ice caps. What do you call a snowman party? A snowball. And the last one, what do you get when you cross a snowman and a shark? You get frostbite. All right, I will see you in class. Good luck on your test.